All right, let's take a look at another instantaneous rate of change problem. Change this one up a little bit from the average rate of change. So let's read this together. The pressure P in bars at a certain depth D in feet in the ocean is recorded by an underwater diver in the table below. So here's basically what happens. As you go further down, okay, into the ocean, the pressure increases. So, for example, when they start out at 75 feet, well, not start out, but when they go down 75 feet, the pressure is 2 bars. By the time they've reached 325 feet, the pressure is 10 bars. So our independent variables up here, our dependent variable would be down there. So X and Y pretty much. Question is, how fast is the pressure? I need to change the wording there. How fast is the pressure changing per 100 feet at a depth of 150 feet? So we know this is instantaneous rate of change. How fast? So we know it's some kind of rate of change at a depth of 150 feet. So it's at a particular depth and it's a rate of change. So we know it's instantaneous rate of change. Next, once we solve this problem, we're going to figure out why this is important. Okay. So any of you who have dived before might know why this is important, but we're going to go ahead and answer it. Okay, so changing per 100 feet. Well, if you go back to this table, you can see that it's going to be easier to measure this per 100 feet, just because we start at 75 and we end at 325. So that's why we want to answer it that way. Because per foot, it's not going to be changing that much, right? So keep that in mind. I'll go ahead and underline that. Ultimately, we're going to be answering per 100 feet. So here's our picture. Now, of course, this is just a particular picture of this person in the water at 150 feet. They pretty much started up at the top. Let's go to my picture, right? And they'll keep going all the way down. So I just drew us a little picture here. All right, convert words to variables. How fast the pressure is changing 150 feet would be P prime of 150. Okay, so somewhere in the middle of that chart, what is the pressure change? Now, how do you figure out the units? Well, it's pretty easy. Okay, you have your independent variable here, X, and your y here. Remember, derivative is change in y over change in x at a particular moment. So it'd be change in pressure over change in feet, but remember, we want to answer in per 100 feet, so keep that in mind. So our instantaneous value is 150. Now we just need to take the derivative, and now you're probably thinking, well, how do you take the derivative of a chart? Well, we've done this before, estimating the instantaneous rate of change of a function at a particular value. There's actually multiple ways to do it, okay? We can either use these 2 points right here, including this one. We can use these two, okay? Or we can use the value before and the value after, which is what I prefer to do. A lot of times when, in calculus, the question will actually kind of tell you what to do. Otherwise, everyone's going to get different answers. But when you have a table, that's the best you can do is estimate, which is what we're going to do. Okay. So when we take the derivative, we're going to estimate at that particular value. So the point that I chose was 100, 3 and 275, 8. Okay, so I did choose the value before and the value after. I'll go ahead and just point those out. There's a reason I do that. It has to do with making sure the tangent line exists at that point, that there's values before and after. Because with a square root function, for example, there are no values before 0 and that kind of thing. All right, so then we just estimate, finding the slope of these 2 points. 8 minus 3 is 5. That's going to be 175 on the bottom. Now, it's per 100 feet, right? So I changed this to 1.7500. And then what I did was I divided the top and bottom by 1.75. So I got 2.86 bars per 100 feet, which is how much it's changing at 150-foot depth. Let's read this answer and talk about why it's important. Pressure is changing around 3 bars per 100 feet, I rounded. This is important because high pressure changes on the body can result in crushed rib cages and even death. death. Yeah, when you're diving, you don't want the pressure to change too much, too quickly. Okay, it can have a really bad effect on your body, and I do believe it also, and it could cause what's called the bends, which can actually kill you. So that brings some relevance to this question, right? If you had some data on diving and you wanted to make sure you were safe, you could pretty much figure out how much the pressure is changing at a particular depth. Okay, so that's it for this question. This was instantaneous rate of change given a chart. If you have any other questions about it or instantaneous rate of change problems, let me know.